Hello and welcome to the Plumbers of Data Science podcast, where I'm talking about stuff that you need to become a data engineer and to work in the field of data science. So today's topic is about networking. It's about not networking between people, it's networking in terms of how is the information, how is the data transmitted through the systems, through the internet, over the air. I think this is super important because when you think about platforms and building up systems and talking about firewalls and so on, you need to understand how is that basically working. So let's get right into it. When we talk about how data is transmitted through a network, we always think first about the actual hardware. You think about switches, you think about routers or routers, and that stuff with wireless access points, wireless routers, and so on. Well, actually, first when I learned this stuff, the interesting thing was having a course from Cisco. There were Cisco courses called CCNA. I'm not sure what these courses are called right now. So when I was in school and after my apprenticeship, I visited a 2-year school to get more into computer sciences, and it's in Germany. It's called State Certificate Computer Scientist. It's a lot about the practical use of computer science, like coding and the networking and websites design and websites creating and creating database and so on. So and one big part of that was networking, and so the Cisco courses, they started very good explaining how the information is transmitted in layers. So you should look into the ISO and OC model. Those are models in layers, how that works. You basically on the bottom have a physical layer. This is the hardware that you're using, the cables and the protocols, basically how the data is transmitted over the cables, and then it goes with each step it goes up and gets more abstract. So at one point you have the MAC address, the media access control. MAC is called media access control, and this is basically the hardware identification of your networking card that you have in your laptop, in your PC, in your mobile phone. It's a unique number. And then you have, and the next layer, your IP address, and so on, and the protocols associated with this. And so you understand basically where the information lies that is transmitted. So on in the bottom layers, it's more like where how is the data transmitted and where does it need to go with the IP address and so on. And then on the top layers, there is where the actual information flows, like your HTTP GET request. This is then in the top layer. So I don't have it because I'm in the car. I don't have it in front of me. So you need to look into this by yourself, and we can discuss about this. Just write me a comment on social media or in my YouTube video. of this podcast. And yeah, so it's very, very important to understand this, because then you have the knowledge of what is a MAC address, what is an IP address, what is a port, what are the protocols, and so on. How does SSL work? This is all the stuff. SSL is more encryption is more one of the top things, top layers stuff. But this is all important, because for instance, one application where you will get into this stuff is when you need to set up a firewall. So let's say you have a platform, you want to create a section of the platform that is only accessible from a different, or from a small number of systems. Then you need to set up a firewall to basically limit access to that zone. And so you need a lot of information of what device sends from where, with which protocol to where, and so on and so on. So yeah, this is super interesting. And one tip I can give you is on how to actually look into this. There's a tool called Wireshark, and when we learned all this, we used Wireshark to actually sniff out our own communication with the internet. So Wireshark is a sniffer tool. You can install this on your PC, and then you can start a monitoring session, and then you see all the packages that are being transmitted over the network, and you can look into all the packages, or you can look into each package on each layer, what exactly gets transmitted to whom. And I found it fascinating to visualize what is actually happening when you, for instance, go to a website or use some service, make an API call, and so on. Yeah, the only problem with websites is once they are encrypted via SSL, you cannot look at the payload. So you need to find something that is not, where the payload isn't encrypted, and then you can basically see the payload that's being transmitted. And this is also why it's important to encrypt stuff, because when you have a sniffer tool and you sit at a certain point in the infrastructure, you can sniff out communication, and if it's not encrypted, you can basically really go into the packet that is being transmitted and read out what forms have been transmitted, the email addresses, and so on. Yeah, so Wireshark is one thing to learn all that stuff and to visualize it. It's a great tool. Yeah. And while I was studying, I've been working at Bosch Rexroth in a department that is especially set up for the whole computer networking, and what they are doing is or what we did there was really install switches, install routers, and so it's a whole world below there, where you need to understand what is a switch, and how does that work? What is a virtual LAN? How the actual networks are splitted below, so they are, you have, this is this is hard to explain in English. You have entities or separate networks within your network, where you have each virtual LAN has a range of IP addresses, and the switches are basically configured to work with certain virtual LANs. Oh, it's a huge thing. I think we could talk about this stuff 50 minutes, an hour, 2 hours, 3 hours. Yeah. The interesting thing is, usually when you think about a switch that you have at home, this is if you have a switch at home, it's nothing you can configure. So it's a switch you can just, you plug it in, put in the Ethernet cables, and the networking is done. But in a complex infrastructure, we have configurable switches, and you have small switches. Then you have layer 3 switches, which are more like routers, and then you have the routers for WAN access, for basically the internet access, and so on. So it's getting quite complicated, but it's interesting, and it's good to know, so that you know how is a network set up, you know how the information is flowing, and also what you need to learn is how the IP address and the subnet masks are working together to build networks. This is also one thing that is important, because a lot of people don't understand this. One piece of trivia: Cisco switches, they have to configure them, they have an operating system, and to run all the switching and so on. And the operating system is called iOS. So it's one interesting piece of trivia, but this is way before Apple created the iOS. I don't know if they, I guess they still use it, use the name. It's an interesting part of software. So where can you learn this today? I'm not really sure. I guess on Udacity, I think there should be some good courses. Maybe one of you has some idea where to learn all this. I'm putting this, when I create an article out of this podcast, I'm putting your answers and your suggestions on where to learn it into the article. The computer networking is also super important when you think about big data, because you need strong or fast connections there. So your servers need to be interconnected with a very potent line. Why is that so? Because for instance, let's look at Hadoop, look at HDFS. What you have there is a file storage with HDFS, a distributed file storage. That means everything you put into HDFS gets split into blocks of 125 megabytes, 256 megabytes, depends on what you've configured. So the blocks then get transmitted over the network through to all the servers, depending on your replication rate, to 2, 3, 4 servers. So with each write, with each block write, there is network traffic between the servers to actually store the data. And then when you access some data, there's also traffic from each server to get the data. For instance, you download it, there is traffic over the network from each server to get the data to you, each server where the data is stored. And this is just one ETL job. Now when you think about stuff like Spark is also a distributed how do we call this now? A distributed analytics framework. So you start a job, for instance, analyze a file of 5 terabytes or 1 terabyte. You need to analyze that file, and that file lies in HDFS. Then, because Spark is distributed, let's say, on 10 servers, and you have your data on 20 or 30 HDFS nodes, then all this stuff is working together. All the data from the HDFS nodes gets used by Spark nodes, and usually, if it works good, it does not need to. If the Spark nodes are on the HDFS nodes, data does not need to be transmitted. But if you have more Spark workers or workers on a different node, you have then again network traffic. So everything that needs to be analyzed needs to be somehow shifted over the network, and with each operation that you're doing, you're transmitting data over the network. So the load on the network with a big data system is super high, and so it needs a strong back end, it needs a strong infrastructure. With cloud providers like AWS or Azure, you have that. But if you're working on premise, this is something to look into. So what many companies do is they attach the servers where HDFS is running onto core switches, because core switches have a very high bandwidth, and so the big data infrastructure is woven into the backbone of the backbone of your IT infrastructure, and can leverage the full power of those core components, which are super expensive. Like a core switch, 30, 40, 50,000 euros is no problem, depending on what you're getting. And so for big data has a high load on networking, and many people forget this when you discuss between, am I doing such stuff on premise or am I doing such stuff on AWS? It's not only the amount of data you have to transmit from the internet or from your source to your cluster. It's also the communication between the cluster nodes, between the services on the cluster nodes, that creates a lot of traffic, and that traffic needs a good, fast, and reliable and expensive infrastructure. And AWS is just giving you this. And in larger companies, there are working a lot of guys in the infrastructure department, networking, IT infrastructure. I think I mislabeled the topic in the beginning. It's not networking, it's IT infrastructure. Yeah. Okay. I'm here. I'm trying to add a new part when I drive home today. Yesterday I tried to do this, but of course my recorder here was out of power, and I did not want to start recording and then lose half the recording because the device shut down. Overall, IT infrastructure, the networking, how is the information relayed over the network? This is super interesting topic, and it's there's always something new hardware. It never gets boring. Okay, so maybe see you later. Hey, I'm back. For you it was just a few seconds, for me it was a few hours, and I think for this session, or for the continuation, I already talked a bit about Linux, so some things I would like to talk about is OS basics, shell scripting, cron jobs, and packet management. Yeah, so let's start. I mentioned earlier the importance of Linux, and it's important because most of these tools or software is running on it, because Linux is basically the choice for server operating systems that you use. Of course you can have Microsoft servers, but yeah, most of the stuff like Hadoop, Spark, Kafka, other tools run perfectly on, or run best on Linux distributions, because they're made for that. And so as a data engineer who is installing tools, who is configuring tools, who is working with tools, you need to know your way around Linux. So it's important to have the main things down. You need to know, you know how to configure network interfaces. You know how to create files. You know how to create files with editors, because you usually don't have a front end on servers, so it's command line editing is very important, and so everything is in command line, and you need to know how to edit files, you need to know how to create folders, you need to know the structure of access rights on a Linux system with different user groups, that you can modify user groups, and that you can modify the owners of files. If you like to do batch operations, how is that working with, for instance, with scripts? So a lot of command line stuff you need to look into, and again, scripting is very important. Bash scripts, you can super easily create shell scripts or bash scripts and run them. Then for instance, you could trigger some events based on a shell script. So you add the execution lines. Let's say a very simple thing, you have a few Java programs and you want to call those things periodically. How do you do that? You create a shell script, you start the Java code from a shell, like with Java, if it's a compiled Java jar, and then you add your jar file and the parameters you're giving the file, and then you put it into the shell script, and then you can start the shell script, and it automatically then starts the procedures that you're doing inside. You can also it's super versatile, and you can do a lot of stuff with shell scripts. The thing is, then what you want to do is you want to schedule stuff, and this one thing is very simple in Linux. You can do this in Microsoft operating systems as well with the task scheduler. In Linux it's called crontab, so you can create very simple. Crontab is like you edit a file, and then you edit some information when the script, for instance, that you have created should be executed, and depending on where you create that file, if you create it as a root or for roots or for users, you also have the access rights then down which the commands are executed. So you can easily with crontab schedule this shell script or bash script that you have just created, and schedule it that it is once an hour, once a day, every 5 minutes getting executed. And it's very versatile. One thing you need to be mindful of is crontab is very very special in one case, because if you edit it and put in your stuff, you need to make sure that you end with a empty line, just with a line feed or a blank, or I think a bash a hashtag also, a hashtag, basically a comment, also works. Because if you end the crontab file with a command that needs to be scheduled, then it doesn't work. It's super annoying. But I guess it's a feature, not a bug. Yeah, and yeah, those are a few very cool stuff about Linux. Another thing is the simplicity of how to install software. On Windows, it's always a hassle. You need to download stuff, and then you need to install it, and yeah, then stuff needs to be put into the registry, and the install process is very hard and very complicated, and it can go a lot wrong on Windows. When you're on Linux, basically everything is more or less standalone. So if you install something, you install it into a folder, and then it's installed. And if you want to uninstall it, just delete the location where your software is installed, and and then it's deleted, it's deinstalled. So super simple. And also how you can manage this is with a packet manager. So if you're on a Red Hat distribution, like CentOS, you're having YAM, and with YAM you can look at the packages that are installed. You can get infos of packages, or you can search packages you want to install, and then you can say, okay, YAM install this, and then it installs it. And if you don't find it, you can add your own resources to YAM, and then have for instance, your own packages installed. One thing, for instance, where you need to do this is, let's say you want to install Cloudera distribution on your servers. On the main management server where the Cloudera manager is running, you want to install the Cloudera manager. And the Cloudera manager, if you type in YAM search Cloudera manager, you don't find the Cloudera manager because it's not in the standard Red Hat package distribution. So what you do is you edit I guess it's the YAM conf, and then you add the archives from Cloudera to it. And so after that you search for Cloudera manager, and boom, there is the Cloudera manager, YAM installed, done. So it's super simple, and yeah, I love it. I have to admit, it's a huge step up from Windows. Okay. Oh, for now this is it. Yeah. Let's talk tomorrow. I think we've covered a lot today, and I'm excited about tomorrow. Bye bye.